Hello, I'm Cyril, and this is my sixth year compiler lab experiment. So the aim is to stimulate the concept of assembler of simplified instructional computer. So moving on to the codes. Here we have all the header files that we require. So now we're gonna start to read the op table. So we are taking in the input through the buffer reader. So inside the program we have the program, inside the enter it's empty for now. It will fill up when we run the program. So I've already run this program. So here inside the enter I have all the values, but when we start it, it's going to be empty. So inside the program I have the program that I have to run. So initially the LC and start are going to be 0, and now we're gonna read the line by using read line, and we're gonna read it until null is not equal to 0, and then we're gonna check if the line contains start or not, and if it does, then we're gonna split it in blank space. Then we're gonna see if the length of C is equal to 3 or not, and if it is, we're gonna parse it giving C2 and 16 as the parameter, and now now LC is gonna get equal to start, and if not, and if LC is start is equal to 0, then again we're gonna make LC equal to start and write it into the line. Else, if start contains end instead of start, we're gonna pass the symbol, and these are the parameters, into LC. And if line contains L, we're gonna write integer the hex value into the LC. Okay, so now we're gonna close the buffer reader and close the write, and now again we're gonna open a buffer reader and input the enter. So now we're gonna run this until it is not equal to null, and we're gonna read the line using the read line. Now we're gonna check if line contains start or not, and if it does, we're gonna print out H and then the title and then the hexa code with the hexa length. Else, if the line is end, we're going to print out E and then the power sign, then again the hexadecimal code of start. Now if the op2 contains key, that is C2, then the object code will be object code plus the 2/6. So here we have gonna give the value, like for example here 03, we're gonna give that value, and we're gonna add LC by 3, so it's gonna jump 3 spaces. Now if line contains reserved word, then we're gonna multiply like 3 times of the pass integer of C3. LC is gonna get added 3 times the pass integer, and if if it contains reserved byte, then it's gonna get increased by the number of integer pass int that is there, and if it contains word, then the object code will become object code plus 2/6 of C3, and it's gonna increment 3 times. LC is gonna increment 3 times. Then we're gonna return LC. Now we're gonna see if OP contains C0, and if it matches A to Z. Now if label already exists, we're gonna write the hexadecimal code to it, else we're gonna print out invalid label name, and LC is gonna get incremented by 3. Else if we're gonna check if C1 is equal to word, if it is, we're gonna write the hexadecimal code. Now we're gonna see if it is equal to reserved word, we're gonna again write the hexadecimal code into LC and increment by 3 times the integer pass int. And if it is reserved byte, we're gonna again write the hexadecimal code, and we're gonna increment the number of times the integer is being passed. and then we're going to return the LC. Now we'll start a buffer reader and put in the opt table. So inside the opt table I have these values. So I'm going to read the line using read line until it is null, and then I'm going to split it on basis of space. So then I'm going to close the BR reader and return the output. So when I run this, I'll get this. So this was the given input, and this input will get converted to this, and inside my enter these values are gonna get. Okay, so this was the sixth experiment. Thank you.